Our next job is to set up our frog so that it is animated. And so we have this frog sprite sheet down here. We've got all the different frames for our animation. If this were a 3D project, we would have made all of our clips in our favorite 3D tool like Maya or 3D Studio Max. But this is not a 3D project. We have to make our animation clips ourselves. Thankfully, it's really easy to do. There is one little gotcha though. Unity's really good at making clips for you automatically as long as you select multiple sprites, but if you do single sprites, then it gets a little confused. So we'll do the easy one first. We'll go ahead and do the frog jump, which is essentially going to be frames 0 through 6. So let's select that, and those are all of our frog jump frames. And I'm going to just drag this and drop it out. I'll just put it out in the middle of the street because he shows up really well in the middle of the street. So I'll do that, and when I do that, it's going to come up with this dialog box. It says create new animation. Let me drag this sort of in the middle here, and I'll call it frog jump. And it's going to make this as an animation clip. So what it's doing is making an animation clip, which is a reference back to the old animation system in Unity, i.e. pre-Mecanum. It's the only way that you can do frame-based animation. And so what it did for us was it actually made this clip for us, and it made a controller for us as well. And so we've got these two things in here, as well as our instance of Froggy jumping. So if we actually run this, we can actually see our clip playing, and there he is jumping in the middle of the screen. All right, so that's part of what we need. We need the other frames as well, right? So there's two other states that we need. We need the frog just sitting there, which is idle, and we need the frog when he's dead. And that's a little more problematic because if I drag a single frame out here, then it's not going to prompt me to make an animation. I'm going to have to go through some extra steps to do this myself. So I'll do that. I'll click Window and I'll click Animation. Make sure you pick TION, not TOR. That's a different window. We want Animation this time. And make sure your Froggy is selected, and it says to begin animating Froggy, create an animator and an animation clip. Well, it's going to do that for us. And what we're going to wind up with we're going to have 3 animation clips, we're going to have 3 animators, and we're going to have a bunch of stuff we don't need, and that's okay. We'll just delete the stuff we don't need. So here's the button we need to click. We've got the frog selected. We'll click create. It's going to prompt us for our animation clip, which I will call frog idle. And now we need to actually animate something. So let's make sure, again, this is still selected. Click frog property and find the sprite renderer, and let's add sprite as a parameter. I just clicked that little plus sign. And now we've got this animation clip where it's expecting the sprite to change, but it doesn't need to, right? So it's going to take us out to 1 second of animation, and it's put this extra keyframe in here. If we wanted to change it, we could, but we're not going to. We're just going to get rid of this second keyframe, and now we've got a single frame animation, which is just what we wanted. Now we need to do the same thing with our dead frog. And there's our dead frog. We'll create frog death as our clip. And then the same thing, we need to add a property that's animated. So I'm going to select the sprite renderer. I'm going to select the sprite, click the little plus sign. It will go ahead and make the tween for me. It will eventually populate it with the little picture. And I'll get rid of the second keyframe. And now we've got a single frame animation as before. So now we have 3 animation clips. And as advertised, let me close this up. We have frog death, frog idle, frog jump. We also have 3 frog controllers, and we don't need those. So let's just get rid of those. We'll make our own. So let's do that now. Let's do create. And we'll make an animation controller, or animator controller rather. And we'll call it frog controller. And we're done with the animation window. I'll just close it. And let's pick this one because that's our frog, basically a single frame animation of the frog. And this was the jumping one, and this was the dead one. So we'll go with this one. We'll get rid of these two. So it's Froggy 0 and Froggy 7. We'll get rid of those guys. Now we've got just the frog. So we've got our animator on here already. It created a slot for it and filled it with one of the animator controllers that we deleted. So let's go ahead and re-add this back in. Frog controller goes right here. And now we just need to edit this. So I double clicked it and now I've got my animator window open. And I'm going to show you the fast way to do this. We could come in here and right click and say create state and say empty and then click it and then find the motion or the clip that we want to use and drag it in there. But there's a faster way. So let's do it the fast way. I have 3 states. I have idle, jump, and death. And the first one I'm going to start off with is idle. So I'm just going to grab frog idle, drag it, and drop it into the window. And it will go ahead and create the state with motion already linked in. So that's perfect. Let's do the same thing for jump. I'm going to drag jump, drop it in there. And now I've got that one. Perfect. And I'm going to go ahead and put death in there too. Frog death. Right there. Drag it, drop it there. And now we've got our 3 states. Now all we need to do is define our transitions. Just like before in our other work with Mecanum, we just right click, select make transition. And we're going to draw a transition both directions from jump, one direction from death because there's no way to come back to idle from death, so we only need one transition. And now we just need conditions for our transition. So let's go over to parameters and we'll add 2 parameters. The first one will be a trigger and that will be called jump. Remember, a trigger is basically a Boolean that goes from false to true and then back to false again, which is perfect for a jump. We want the jump variable to set, we want the action to be performed, and then we want it to be reset back. And we don't want to have to write any code to manage that. So trigger is perfect for this. Let's find our transition out of idle and into jump. And let's add jump as our condition. And then coming back, we don't need anything. We do need to turn off these has exit time settings though, so that it will come back properly. All right, so we're just going to use no condition here, and this should work okay. Same thing on frog death. We'll select has exit time to turn it off, and let's change the condition to, we don't have one yet. Let's add a parameter called is dead. This will be Boolean because he's either dead or he's not. Is dead, and that will be our condition here. So I'll select the transition, change it to is dead, and that should be all we need to do. So let's save our scene. Let's go back over to our scene window and let's run it. And it would be handy at this stage to have our animator side by side with our scene. So let's switch back to our scene and I'll pull my animator out so we can have them side by side. Okay, so we can see our frog. We can see he's in the idle state. If I click jump, he should jump. And he's not transitioning back, so we'll fix that in just a minute. Let's go ahead and test dead. I probably shouldn't have turned that second has exit time off. All right, so we'll run this. He's sitting there. Everything's great. Here comes a truck. He's dead. Okay, so that's fine. So that part worked. We just have the one transition to fix. Let's turn has exit time back on. And that's probably all we need to do. Okay, so he's idle. Now he jumps, and that's what we want to see. So eventually it's going to be when we click a button, then he's going to jump. And if he gets hit by a car, then he's going to squish like that. Okay, so the frog is pretty much set up and ready to go. Make sure we've got our scene set and saved. And it's on to the next task. Now that we've got our frog animation set up, why don't we configure our script so that we can actually control the frog's movement. So let's go. I'm done with the animator window for now. I'll go ahead and close that. And I'm going to go ahead and create a script on the frog called Froggy Controller. And let's go ahead and open this up. You may need to change your settings. I wanted to remind you of that before I switched to the editor, since sometimes at school we get odd results when we try to pick Visual Studio. So let me just remind you where the preferences are, and it's Preferences under Edit, and then External Tools, and then just select the editor that you want to use. I'm kind of feeling like using Visual Studio today, so I'll switch it. And now I can double click here and it will open. And it will take a minute, so let me pause the video briefly. So with our editor launched, let's get some of the basics out of the way. We want this to work based on our arrow keys, so let's go ahead and get our code in for the basics. So I'm going to put this in update, make this a little bigger to make sure everyone can see it okay. And I'm going to add a couple of variables in here. So I'm going to call the first one left right, which will correspond of course to the left and right arrow keys. And I'll use our usual get axis command from the input class to detect whether or not that button has been pressed. So we're going to get horizontal. Make sure you spell it correctly. And now I'll go ahead and do the other axis, which I'll call to and fro. Actually, it came in as to from. I meant to put to and fro. Get axis, and this one's going to be vertical. Again, make sure you spell it correctly because it has to match the setting that's in the axis settings. All right. So from here we have a few problems that we need to solve, and let me go ahead and save this and switch back to Unity just so we can sort of illustrate what this is. So we've got our frog and he's facing forward. If we want him to jump to the left or to the right or even backwards, we don't really want him to be facing up, right? We're going to have to rotate him so that he's actually jumping in the direction that we want him to be jumping in. And of course, this is fairly straightforward. We're just going to manipulate his transform. As usual, he has a transform, just like every other game object in Unity. Since he's a 2D object, he only has 2 dimensions that we really need to deal with. And so all that's fine. So we're going to have to figure out how to do that. So he's going to have to jump in a direction, and he needs to be facing the direction that he's going to be jumping. The other thing that we need to figure out is how far he's going to jump each time we press the button. And so we're going to have some sort of variable to account for the distance that he's going to travel. And then finally, we need to figure out a way to make sure that he can't just continuously jump. So for example, if it takes a second for him to jump, or even a half a second from one place to another, we don't want him to jump 1,000 times a second or even 60 times a second, which would be too many. That would look weird. So we need to account for all these things. Many of these are problems that we've actually solved before, like the one where you only want him to jump maybe once a second. That's the same thing that we covered in our projectiles lab, where we had to make sure that you couldn't shoot 1,000 bullets every second or 60 bullets every second. You just wanted to be able to shoot 1 bullet every few seconds. So these are problems that we've by and large solved before. We've played around with rotations and quaternions and things like that. So these are things that we've done before for the most part. All right, so with all of that in mind, let's switch back over to our code editor, and let's start to put some of the variables in place that we know we're going to need. As mentioned, we're going to have some sort of distance calculation. So I'll make public float jump distance, and I'll just sort of arbitrarily set it to 100. I'll make a private float called next jump time, and I'm going to set that to half a second. And I need an F there. There we go. Finally, I'm going to put a couple of things in here. I'm going to do public float jump delay, and I have to spell it correctly. There we go. That will also be 0.5f, and we'll just use this in a count up fashion. You'll see what I'm talking about when we actually do it. We are going to need a reference to the animator, so that's pretty common. So we'll add a reference to the animator. We'll call it frog state. We're going to need the final location. So when we actually do the jump, we're going to compute the final location, and then we'll animate the frog to that position. And so I'm going to call that one end position. Sounds good. Okay, so that is probably enough to get us started. Let's use our start method handler to sort of set some of these things up. We know that we're going to get the component off of the animator, so let's set frog state equal to get component animator. And so now we have a permanent reference to it. Let's start our end position. We'll go ahead and initialize it to the current position of the frog so that they're the same. And then we can just use an offset when we actually make this work. So we'll do transform.position is going to be the starting position for the frog. Likewise, we'll go ahead and set a starting rotation. We'll just say transform.rotation equals quaternion.identity, which is essentially a rotation of 0 for all intents and purposes. All right, so that's good. We're set up there. Why don't we get our basics working? Let's come down here and let's add a few if statements so that we can detect which button the player is pressing. So we'll say if left right is greater than 0, and I'm just going to leave it like that for now. We would normally want to go ahead and put in the jump time calculation to make sure that we can't do this over and over again, but for now let's just get our arrow keys responding correctly. So we'll say debug.log left or right. Okay, and I misspelled log, so it's capital L. So let me fix that. And actually, I'm assuming that's going to be the right key, not you should be jumping left or right. It probably is you should be jumping right. Okay, likewise, we will just come down. Tell you what, I'll show you a trick. I'll just add an extra line here. I'll select one line past, hit Control D. This only works in Visual Studio. It doesn't work in MonoDevelop. Okay, so that duplicates the line. I'll tab it over so that it's aligned correctly, and this time we'll just say less than 0, you should be jumping left. And let's see if that works as expected. Make sure I have my left and right figured out correctly. I'm going to move this back over. There's a format code command, but it's just 3 lines, so I'm just going to do this. I've selected it. I'm going to hold down Shift Tab and move it back to where it goes. All right, so that's good. Let's switch back over and see if that is intercepting everything correctly. We should be able to run this. And on our console, when we select left and right arrows, we should be jumping left and jumping right, and it looks like I have them lined up correctly, so that's good. All right, let's switch back over. And let's do up and down, to and fro. I suppose I put it as. Okay, same thing as before. To and fro is greater than 0. Debug.log. We'll put jumping forward. Okay, and I'll just Control D it. change it to less than, line everything up so it's a little nicer, and let's see if that works. Well, we need to change this to backwards, which I guess would also be down. Switch back over to Unity, let's run it, and let's press the up key, and that's forward, press the down key, and that's backwards. And it looks like everything's good. All right, so let's do a little bit more with this. So first we'll go ahead and set this up the right way. So if left right is greater than 0, he's going to be jumping to the right. And just so we can remember that, I'll go ahead and put a comment in here. And we can take out the debug because we know it works. All right, so let's put everything we need in here to get this working. So we'll say we need him to actually rotate so that he's facing right. So I'm going to say transform.rotation equals quaternion.identity. Basically what I'm doing each time, I'm going to do this on all of them, I'm going to go ahead and reset his position to 0. This prevents me from having to calculate a rotation relative to the current rotation. So let's say your frog is facing left. If I want him to then jump right, I would need to rotate him 180 degrees. If he were facing up, I would only need to rotate him 90 degrees. If he were facing down, I would have a decision to make. I would either need to rotate him 270 degrees or negative 90 degrees. And that's a lot of logic. So I'm going to reduce the amount of code that I need by setting him to identity each time and then changing him from that to whatever I need him to be. So if he's facing left, I'm going to make him face up, and then I'm going from the up position, it's very simple to make him rotate in the direction that I need him to, and that's just going to save us a lot of time and frustration. Okay, so we're going to set him to identity, and now we're going to rotate him. I have to spell it correctly. Transform.rotation equals, actually, let's do transform.rotate, not transform.rotation. We'll actually use the rotate method. And it takes a vector 3, and so we're looking down, and so our coordinates are going to be 0, 0, 0, 0, and negative 90. So remember, when you're doing negatives, it's going to rotate clockwise versus the other way. Positive numbers is going to rotate him counterclockwise. That's pretty common in most animation platforms. Again, the other way would be to rotate him a full 270 degrees around, but that seems silly, so let's just do negative 90. And then if we want him to go the other way, he's going to be positive 90. So remember that when we do the left side. All right, so let's calculate his end position. So his end position is going to be relative to his current position. So we'll say end position is new vector 2, and we'll say it's transform.position.x plus the jump distance. And then we'll say that's x, and now let's do y. He's not going to move along the y-axis, so we'll just do transform.position.y. So that'll be the same. So remember, x is left and right on the screen, y is up and down in a vector 2. That's what we want. So we're making him jump to this way, to the right. When we do left, we'll probably just subtract, right, to make him go the other direction. Okay, so we've got that, and did we ever set our, no we didn't. Okay, so let's do that next. So we want some sort of delay in there, so we'll say next jump time. Next jump time equals, time.time, which is the current running time of the game. So when you start the game, it starts at 0 and it just starts ticking up. And so we're just going to use that running time, and we're going to say time.time plus whatever the jump delay is. And that'll be the next time that we're able to jump. And then we're going to go ahead and make sure the frog is animating. So I'll say frog state dot set trigger. And if you remember, we called it jump. One more thing we need to change. Let's go up to our if statement, and let's change this so that it takes into account that that time.time variable we just set. So we're saying time.time. Oh, and we need an and in here. There we go. Time.time greater than next jump time. Okay, so as long as time is ticking forward, we've set this variable next jump time to be a half a second away, and it's not going to actually allow us to do any of this until time.time is greater than next jump time. Pretty simple, straightforward way to delay this. Let's do the same thing over here. This time we're jumping right, so we're literally going to copy this. I'm just going to do this. I'm going to be efficient, not lazy, but efficient. And I'm just going to come down here and paste it in there. And now we've got a good delay. Most of this is going to be almost identical. So let's just do transform.rotation. Again, we'll reset it to quaternion.identity so that we can compute everything from a common location, i.e. the frog being forward. And now we have transform.rotation. He's pointing up. And as advertised, we'll just do transform.rotate, and we'll do the same vector2 thing, or the same thing that we did last time. We'll do 0, 0, and 90 this time. Remember, he's going the other direction. All right. Same thing as before. End position is going to be computed the exact same way, but again, as advertised, we're going the other direction. So we'll do end position equals new vector2 transform dot position minus dot x minus jump distance to make him go the other direction. And then we just go ahead and use transform dot position dot y for the y axis. And now if you're thinking forward, it's pretty easy to figure out what we're going to do for the next phase. We're just going to be manipulating y instead of x. All right, so we've got our end position. Let's do our next jump time part like we did before. So next jump time equals time.time plus jump delay. And there it is. And let's do our frog state again. Frog state dot set trigger. And we'll go ahead and fire off jump just like we usually do. And now we've got left and right, and that should be all we need. Let's go ahead and do to and fro. So, or forward and back if you prefer. I'll do the same thing I did before. Should be jump forward, just so I can keep them straight. And some of this is going to be the same, so I'm going to do transform.rotation, and we'll set it to quaternion identity. And now let's do in position. It's just going to be, again, a new vector2 like it has been the last two times. This time, though, we're manipulating y instead of x. And so let's do transform.position .x. Since we don't need to manipulate x, we're going to manipulate y this time. And so we'll say transform.position.y plus jump distance. What did I call it? Oh, it's an uppercase J. Okay, jump distance like that. Okay, and then we'll do our time computation as usual. I'm starting to see that we're using a lot of the same code over and over again, which usually means you should probably refactor this later so that you don't have so much repetition. But I think it's good for people that are just getting used to this stuff, and I think at this phase, Hopefully you understand what I'm doing, but it's good practice to type this stuff over and over again. That's how you learn it. Okay, so we'll do next jump time, time.time plus jump delay, and we'll do the frog state, which is jump. Okay, same thing as before. I'll be lazy this time, or efficient if you prefer. Except this time, instead of adding, we'll be subtracting. And the rest is the same. Okay, so we've got all that. At this stage, we're not actually moving our frog, though. All we've done is we've computed the end location. So in all of these cases, we're going to be moving the frog. And so let's do this. Let's do transform outside of all of these if statements. Let's do transform.position equals vector2.lerp. This is one of the ways that you can animate with code. It's a linear interpolation. Basically, we're just changing the transform.position, obviously, since that's what we're manipulating. But a lerp will do a linear interpolation between the starting point and the ending point. And it just makes life pretty easy. You don't have to compute anything. It does it for you. So we're going to do transform.position, which is the current position of the frog. And then we'll do end position as its final stopping point. And then the third thing that you need here is going to be some sort of distance or some sort of time factor usually is what you put in here. A lot of times you'll use time.delta time to smooth things out. Pardon me for just a moment. Sorry about that. Like I said, still getting over this cold. For my experimentation, I just fiddled around with it and found that 15F worked for me, so I'm just going to put that in there. And that should be okay. I think that's all we need in here. Just give it a quick look. There's nothing red. I've got some yellow in here, and that's because I'm using a refactoring tool called ReSharper. You'll see I have an extra thing up here that you probably don't have, and so it's telling me there's some things that I could fix, like I'm not using collections, so I should be able to take that out. A few things, though, I can't fix, like it's going to tell me that the namespace is wrong, and that's because of the way Unity works, so I'm not going to fix that. It really wants me to name this jump delay for, oh, it's because I made it public. I didn't really mean to make it public. I meant to make it private. You'll note that it's not complaining on the one above it. So it's kind of making sure that I'm following the naming conventions, and that should be probably all of it. Is there anything else in here? It's going to say update is never used, which is of course not true. It just isn't used in a context that ReSharper knows anything about. So ReSharper is a tool for C# development. It also will help you with C++ development if you do that. And it doesn't know anything about Unity. It's just gauging this based on purely a C project. So there's going to be a lot of things about Unity that ReSharper just doesn't know about. So you can't really go, if you can't really use this the way you would use it in a regular C# production application, which is fine, but it still does a lot of neat things for you. So it's a neat tool. If you can get a hold of it, then great. It's from a company called JetBrains. All right, so that's great. This looks okay. Let's switch back over to Unity and see how we're doing. And I don't see any compilation problems yet. All right, so let's see if it works. We should be able to click play, and we should now be able to click, oh no, he went away. Now he didn't. You can kind of look at the numbers and see what happened. He jumped some distance. Let's jump backwards and see if he comes back. Okay, I saw him there for a second. So we've got too much of he's moving too far is basically what's going on here. So he's jumping this gigantic galactic distance every time. All right, so, and that's going to be a little different. Sort of every time I put this project together, it's probably coming together at different scales, which is going to be just normal Unity development stuff. So jump distance is 100. That's obviously way too big. Let's set it to 10 and see if that helps us. And now we can at least see that he's doing something. So 10 is even too big. So why don't we go with 1? And let's see how that does. Okay, so that's a little more reasonable. We're not turning, though. Oh, we're turning this way, so that's good. And there seems to be a pretty big difference between jumping up and jumping down and going backwards. So we've got a few things to debug. Let's go take a quick look at our script and see what we can see. All right, so first thing I noticed, he's not turning. So I must have forgotten to rotate him, and it looks like I did. I just jumped in there and did the other part of it. So let's do, how did we do it before? Let's just go back up and see what we did. So we did transform.work. Okay, so we didn't do anything on this one, and we reset him, but we never rotated him around. So let's just flip him over 180 degrees. That's just transform.rotate, just like it's always been. And we're going to do 0, 0, 180. Now, one of the things you might have noticed is that sometimes we're using vector 2 constructs, and sometimes we're using vector 3. And this is just a side effect of the fact that the 2D capabilities in Unity are still fairly new. They're getting a lot better with every release, but there's still a lot of things that still expect a vector 3, an X, Y, and a Z. And if you're looking down on a game, you're looking down the X and the Z axis, not the X and the Y axis. And so anything that takes a vector 3 is going to expect you to be manipulating X and Z. Anything that takes a vector 2 naturally is going to be expecting you to manipulate X and Y, because there is no Z in a vector 2. Okay, so that will hopefully solve our rotation problem. And now we should be able to jump backwards. Okay, he's jumping backwards. He's still jumping really far, though. So he's jumping a distance of 1, but when we go left and right, he's not. He's obviously jumping some other distance left, and that's really what I would want. So let's see what the difference is between the code where he jumps left and right and the code where he jumps up and down. So we're doing transform.position.y, jump distance there and there. We're doing the same thing here, jump distance X and Y. But obviously there is some difference between the directions. Okay, so I've got our frog jumping around. Why don't we go ahead and put a car on the screen? So let's find our 80s SUV, which is just what the modeling program called it. And I'll put it out there. And it looks like I need to do a little bit of resizing. So I'll just resize it up a little bit so that it looks like it fits in the lane correctly. And that looks all right, so we'll save this. And now we just need that car to move. So we're going to need a script for that. I'll add a new script, and I'll call it vehicle controller. And that sounds good. Now we've got our vehicle controller. We just need it to move. Let's go ahead and open our script. And this is actually a lot simpler than the frog script. We're just going to simply move it. And that's pretty much a one-liner. So wherever it is, we're just going to say transform. Oh, there is one thing we're going to need. We're going to need a variable at the top. Before we do the transform, let's do that. We're going to need a speed variable. That's probably not a surprise. So let's do public float speed, and we'll just set it to 1f as a starting point. We'll see how much that moves things for us. All right, back to our one-liner, transform dot, before we did rotate, this time we're going to do translate. Translate just means move something. All right, so our translate wants a vector3 translation. So let's give it one. We'll do vector2 dot right. That's the direction we want it to go. And that's pretty much all we need to do, except that we want to smooth this out a little bit. So why don't we do time dot delta time times speed. And so the time dot delta time will just take into account how much time has passed since the last frame, and then we're going to multiply that by speed. If we don't put this in, sometimes your animation is going to be really jerky. And so this is a good way to mitigate sort of jerkiness between different platforms that might run at different speeds. So your desktop machine runs frames per second a lot differently than, say, your iPhone or your Android phone does. And this will sort of really mitigate those frame rate differences. All right, so that's really all we need to do. Let's see if it works. We'll run it and switch back to the scene. Let's see where our car is not moving, so that's not good. Let's try, I don't see, we must have an error because I don't see our parameter there. So let's go see what I did wrong, if anything. Okay, my build succeeds. So where's my parameter? Okay, there it is. It just took a minute. I was impatient, I guess. Let's see if it works now. And there it goes. It's moving kind of slowly, but it's moving. And it should be in the game now. So I should see it in the game window come across very... That's a Sunday driver right there. So we can adjust our speed if we'd like. Maybe to 2. And let's see if that's better. And that's probably about right. Okay, so it's just going to keep going pretty much forever. You can sit here and watch the numbers change. And that's a good starting point. That's basically what we need to get this going. But naturally, we're going to want more than one car, and we're not going to want to drag all the car instances out that we're going to be using. So what does that lend your thinking to? Probably you're thinking, and at least I hope you're thinking, we need to make a prefab out of this and then instantiate multiple copies of it. Hopefully you got that first part. The second part, if it's a little foggy, well, you're still getting your sea legs, right? So we'll make this into a prefab by dragging and dropping it down here. And so there's our 80s SUV prefab. And now we just need to instantiate this. Well, if we're going to be instantiating anything, we need to be doing that from a game controller, right? So we have this script that controls our car, but it's not going to know how to instantiate multiple cars, and it's not going to be able to track multiple cars. As a general rule, your script that's on an object to control that object only, and it shouldn't try to instantiate multiple copies of it and manage multiple copies of it. That's the job of a game controller. So let's go back to Unity and make a game controller. So I'll just make an empty game object as usual, and I'll call it game controller. I'll tag it game controller. And I'll add a script to it called, you guessed it, game controller. All right, let's open our game controller. And let's set a few things up. Let's do, we're going to need a transform, which will act as our spawn point. So why don't we do that? We'll say public transform spawn point. Now in reality, there's probably going to be several of these, but why don't we start with that? And then we're going to need a number of other things as well. Probably though, oh, we're definitely going to need a reference to the car itself. So we'll do public sorry, not transform. We'll do a game object, and we'll call it car prefab. Okay, so that's a good enough starting point. We'll have to do more, obviously, because we're going to need some delay between car spawning and things like that. But let's just start with this. So those objects, we're going to be dragging and dropping references for the spawn point and the car prefab. So let's go back over to Unity, and that actually, where it is right now, works as a spawn point. I could probably move it over a little bit. We can see that that's where it's going to come into being. And so right there is pretty much where I'm going to want my spawn point. So my spawn point, why don't I just do this? I'll create an empty game object, call it car spawn point, and I'm going to go ahead and set a label on it so that I can see it, and I'll use orange, and there I can see it. And now I want to move this car spawn point so that it's right about where our car is. And so it's at 8.07 and -4. So why don't we just change this to 8? Let's see if we can get away with 8 and 0. Sorry, -8 and 0, obviously. Okay, good. So -8 and 0. So that's our spawn point. And I like it when it's nice even numbers that work out. So that's nice. And so now we have the spawn point. Let's go to our game controller, and it should pick up our 2 new properties eventually, assuming we saved our file. Let's go back and save our file, make sure it's all saved. They're public, so it should be there. And there we go. All right, so spawn point and car prefab. So our spawn point is just car spawn point. We'll drag and drop it there. And our car prefab, that's going to be our 80s SUV prefab. So we'll drag and drop that one in. And that means we can get rid of the one that's currently on the screen. And there we go. Oops, I hit the wrong thing. Get rid of the 80s SUV. And when I deleted car spawn point, that probably messed up my association. Oh no, it didn't. Okay, good. It's always good to check though. Usually if you delete something, you're going to have an empty spot here, but undo apparently brought it back. So there it is. So there's our scar spawn point. I can't talk today. Our car spawn point is there. Now it's set up in our script. Now all we have to do is our usual shtick where we instantiate the car. So let's go see if we can pull that off. So to do that, let's do instantiate. And if you're screaming, I know I haven't done anything with my time delay yet. So if I really did it this way, you'd get 60 cars a second. That would be a big mess. So don't be too gung-ho to hit play just yet. So let's just get this code in there and we'll get it going. So the instantiate command takes a couple of arguments. It wants what to instantiate first. So that's going to be the car prefab. And then where do you want to put it? That's going to be spawn point. And then it wants a quaternion, so just give it quaternion.identity, and you're all set. So that's it for spawning a car. Except it doesn't like this. Oh, that's a transform. It wants the position. There we go. Okay, now we're good to go. Okay, so now we need to put this time delay in that we keep talking about so that we can get 60 cars every second. Not even Detroit can do that. So let's say if time.time, we're going to need a variable up here, aren't we? So let's do private, and we'll call it last car. How's that? It's going to be a float. And then we're going to need some sort of time delay. So we'll call it car time delay. Actually, we might want to make that public. And I think that will be all we need. All right, so we'll come down here and we'll say if, essentially we're going to do the same thing we did with the frog jumping. We're going to say if time.time is greater than last car. So last car, we should probably go ahead and instantiate that to something low. Actually, we can just instantiate it to 0 as I think about it, because we want one to pop in there immediately. So why don't we go ahead and set that to 0, and our car delay, why don't we put a 2-second delay on that? So we'll say 2F. Okay. So if time.time is greater than last car, which is the last time a car came out, let's go ahead and enclose the rest of this in our braces. And we just need to say, from here, we want to do our time calculation. So we'll say, if it's there, then the next time we'll see one is going to be time.time plus time between cars, or whatever we call it, car time delay. Okay, and then we instantiate the car. Time.time. Let's see, just make sure this is right. I think this is right. Yeah, this looks good. Okay, so let's give it a try. Of course, we're going to have another problem because they're not ever going to die, right? So, but let's just take it one at a time. Switch back over to Unity. Let's run it, and let's see what we've got. So we should be able to see... Oh, we did we actually... We didn't start it, did we? Yeah, we did. Except I'm not seeing anything over here. So I was probably too quick. Let me make sure it built. Game controller. There's the prefab stuff. It should pretty much run immediately. Okay, so something's messed up. Let's see. Update of time. Time is going to be last car. Time.time greater than last car. So it's greater than 0. Then we do that, and we do that. And let's make extra sure that it's on the game controller. It is. Game controller script. Looks okay to me. Let's just throw a debug statement in here real quick. Okay, let's make sure that's even running. And mine is not. So let's see what's going on here. Okay, rebuilt it. Let's try that first. And there we go. Just needed a little coaxing. Okay, so now we've got an instantiation happening every 2 seconds. And this looks exactly like the original Frogger game, right? And we've got a few things to do yet. We have to put colliders on the frog and on the cars. Nothing happens at this stage if we run into one. But yeah, that pretty much looks like it. Now we do have a problem as mentioned. That we've got all these cars showing up over here. They're not ever destroying themselves. So why don't we take care of that? That's a pretty straightforward thing to do. We should still have our vehicle controller over here. And so what we need really is just an upper boundary on where it can go. So let's switch back to Unity for just a moment and let's see where it is that the car can go. I'm going to do a little bit of a trick here. I'm going to pull one out and put it right there. And our starting point isn't a problem, it's our ending point. So let's see where our ending coordinate is. Once it gets off the screen, it's at negative 0.3, I could probably get away with taking it to 0, and that's fine. And then 7.93 is the x-coordinate, and it looks like it passes out of the frame at exactly 754, so why don't we just say 7.8? So if x ever gets above 7.58, the vehicle should kill itself, essentially. So why don't we change this so that it says if transform dot position dot x is greater than, and what did we say it was? 7.8, I think is what we decided. 7.8. We could go with a hard 8 if we wanted to. It wouldn't kill us. I like round numbers. Then we're going to kill the game object. So we'll just say destroy game object. And now they'll disappear as soon as they reach that point. Now, if we ever have them going the other direction, we should check what the boundary is for the other direction. Maybe that's what we'll do next, but let's just see if this works. Okay, so there they are. We might want to up the delay a little bit. That looks like it would be kind of hard to squeeze through there. Maybe 2.5 seconds would be better. But we should not see too many of these over here. In fact, looks like our number is going to be 4 on the screen at a given time, which is perfectly manageable. That's fine. Let's change this to 2.5 and see. Oh, I never took this one off. But of course it killed itself as soon as pretty much immediately, so that's fine. Okay, so that's good. I was going to try changing the delay on game controller to say 2.5 and see if that gives us a little bit more room between the cars. It should. Okay, that's a little better. So I think we can probably make it through there, and we can play test it a little bit, just see if I can, yeah, easily make it through there without getting squished. And it looks like we don't have our adjustment on the forward and backwards motion, but that's okay. All things that are easy to fix. All right, so that's good. This is looking pretty good. I guess our next thing is going to be to figure out how to handle collisions. So we'll do that next.